Hello everyone. So in today's video, we are going to discuss how we can set up the C++ development environment in Visual Studio Code. Let's call it Visual Code. So we will discuss about how we will set up the CPP debugger, CPP Intellisen, or we can say autocomplete and all, and few other features. So we will discuss all these things in stages. In first step, we will discuss how we can set up everything so that we can get a simple C++ program running. Then we will discuss about how we can build programs, or basically the process of compiling. Then we will move toward debugging of a C++ program. And finally, C++ configuration, some of the essential parameters configuration in the C++. Let us move to the first step. So first of all, you need to download and install Visual Studio Code, obviously. Once you have downloaded it, okay, I have already in my laptop. So here I'm just opening it. So once you have downloaded this one, you need to install the C++ extension. So in Visual Code, there is a concept of, let's say, yeah, here you can see that what all extensions are installed in your Visual Code. So here you can search for, let us say that I just uninstall this one, okay? And again, I can search it using C++, and then this is the first option which is coming. Then I can select and install it basically. So this will install Intellisense debugging and code browsing utility in your Visual Code. Once it is installed, now what you need is you need a compiler basically, a G++, GDB, and GCC utilities which will compile your C++ code. So you can download that for the Windows machine. I'm demoing this for the Windows machine. So you can download this from this particular URL. You are going to download the minified. I'm not sure what is the name, but I think that it is something like minified GNU Windows 64 version, something like that. So based on your system architecture, whether it is 32-bit or 64-bit, you will download your version. I have already downloaded in my system for my Windows 64 version. Once you have downloaded it, you can simply launch this executable, and it will launch the installer. So it is already installed in my system, but just for the sake of the demoing, I am showing it that how it look like. So here you need to select the latest one, 8.1.0 as of today's date. Your system architecture, like if it is 64-bit, you need to select this one, x86-64, otherwise 32-bit, this one. Okay, so my machine is 64. POSIX, obviously, it is not Windows 32 application, and other things fine. Next, when you click, it will ask you to download in program files. This is the path where it is going to download. I have downloaded for my machine in this particular path. Everything is same. Just I have edited this with the name MING Windows 64. This one. So this is downloaded over here in my machine. C drive MING 64, and that's the same path. So this is the path. So I'm just canceling it out because in my machine already it is downloaded. Yes, aborting the. Once this is downloaded, what you need to do is you need to tell your machine that where these executables are. We are especially interested in this one, g++.exe, gcc.exe, and this debugger, GNU debugger, gdb.exe. All other are also important, but we are going to use directly these three. So we need to provide this path to a machine such that it will know that from which path these executables are coming. So we can provide it using the system variables. System variables, you can set it from your My Computer, right click, more advanced properties, and then system variables. Just click on this advanced system settings, and then environment variables. Here, go to the path for your particular user. Okay, go to the edit, and then at the end, at the last, you just add this one. For example, I'm deleting this one. Up till the bin, you have to provide the path here up to the binary, because this is the path where your executables are lying, right? So once this is provided here, just do the same, exactly same thing in this your system variable. I have already provided it. Done, done. Okay. So once this is done, what you need to do is just go any of your folder to your machine. For example, I'm going to this folder. Okay. And you can open at this folder your command terminal with the cmd command. Here is my command terminal. And then let us just verify that those executables are getting accessed or not. So g++ minus the version I'll do, and it will tell me the version. Similarly, gdb minus version I will do, it will tell me the version. So it means our path is set correctly, and now our visual code is ready to be used as a simple C++ development environment. So let me close this, and for example, at this particular path, I want to open my visual code. How I can do that? So let me create a simple directory, um, CPP code workspace. Okay, and I want to open my visual code here. So I will just write the command code, which is for launching the visual code, and at present directory. So it will launch it. Great. So once this is launched, already we have installed the extension. Please notice that I have only installed this particular extension for this demo. Okay, there are other extensions also like C++ Intellisense. Please do not install any other thing. Why? Because already the Intellisense is coming with this particular extension, C++ extension. This is the one. Just remember this purple color logo, and it is from the Microsoft. Do not install any other extension which is coming from some other organization and which is giving the same facility which is already available in your extension. Okay, this is very important. People get confused sometimes. Okay, so now once this is done, let me just create a simple file. Let me call it as test.cpp. And just to complete it quickly, I'll just show you. Okay, hash. So you can see that it is auto completing. So I'll stream dot something like that. So it is auto completing. Let me just bring a simple code in the C++, and I can copy paste. So this is a simple code in C++. I have just copy pasted it. Here what I'm doing is I'm just creating a queue container from the STL in the variable queue. Okay, I'm just printing some hello statement. There is a for loop from I is equal to 0 up till 5. It is breaking at I is equal to 3. At the end, I'm again inserting, I'm pushing a value 100 into my queue int. Okay, these are not important. This will be used when we will just see the debugging process. And then there is a small vector having 3 strings in it, and then I'm printing those 3 strings. That's it. So let me just run it. So I can run it from here, this run code, and it will run it. So I can see that this one is getting printed from cout queue empty. So it is checking that whether my queue is empty. Question mark. So it will tell me whether my queue is empty. Okay, then there is this just cout in statement. Okay, printing a statement, and then 0 1 2 it is printing. At the 3 it is breaking. Queue is empty or not, it is again checking. So because we have now inserted 100 over here, so it is obviously not empty, so 0. Otherwise earlier it was 1. Okay, and then we have a vector of strings, and it is printing all the words in it. Okay, all the items in it with a tab separation. Done. Great. So our focus here is that now our C code is working in Visual Code. Also, please notice that not only the C++ keywords it is auto completing. For example, when I am printing hash, So it is telling me that, these are all the options which I can choose among. And also it is also printing, it is also auto completing the user defined variables and the functions associated with it. So for example, q is my q, okay, q stack. And now you can see that when I'm printing typing dot, it is telling me in the autocomplete that what are all functions available with the q. Okay, so great. So now our autocomplete or Intellisense is working completely. So we have seen that, how we can set the path of the MING binary in the path variable. We have tested that our setup is complete, and then we have seen a simple demo of the C++ code. So if your goal is just to set it up, the visual code for C++, this is it. If you are more interested to further continue, you can see now, okay, how we can build the programs, process of compiling. So in the G++, okay, compile and running a C++ program default executable. So what we can do here is, um, yeah, here in the terminal, if you go here and click on configure default build task. So please notice one thing here. We have just created one C++ code, which is test.cpp. Other than that, there is nothing in our directory cpp_cw. Okay, this is our cpp_cw. Just two files. One is what we have written, and one is the executable of it. That's it. Okay. So right now, this directory cpp_cw is not a workspace. Basically, it is just a plain old, a normal directory, Windows directory. That's it. So as soon as we will start applying a different configuration in the visual code, it will start preparing those information saved in a file format. So now when I'm going to this configure default build task, so that I can build my, or I can compile my C++ code. So I will select here C++, this build active files. So with the active files, what it means is the file which is right now opened. This is the active file, test.cpp is active file. So I'll just select it. As soon as I will select it, okay, you can see here it has generated one directory called .vs code. And inside that, there is one file tasks.json, which is this one. So what happened, generally it is a convention in all operating system like Windows and Linux, that any directory which has a name starting with dot is generally system directory, like, the system, the operating system is using it. So operating system, or you can say that Visual Code, has created this particular directory .vs code, and inside that task.json. Okay, so inside that, what is the things? This is version and all the descriptions according. Important thing is that the command. What is the command it is going to launch for building an active C++ code? So this is the command. So you can see that it automatically picked correctly the executable for the CPP. See, this is our bin path. So it has picked it from the path variable which we have just set it, okay, in the system variable. And then we have arguments also. The arguments are -g and then the file, and similarly -o, which is for the output file. So this one. Okay, so from here, what you can understand is that one way of running the .cpp is simply, go to this file and then click this run code. It will do. It will, generate a .exe, which we have just seen now, and then it will run it into the output console. This is our output console. But from here, we can learn that, using the CPP executable, or I feel G++ also works here. G++ or CPP executable, if you will provide the -g option for the file name, .cpp file name, and -o option, it will give you the .exe file, and then you can run directly .exe. For example, if I go to the terminal and the same path, here cpp_cw, right now I am. So what are all the paths available here? Test.cpp and test.exe. So if I just launch test.exe, Okay, and I click enter. So you see the same effect what the running code was doing, it is giving me here. So this is an executable file which displays this much output in my terminal. Same thing, it was done in the output. So while I was running this run code, it was compiling the program, or we can say the building the program, CPP program, and then also running the executable which was generated. If your program had certain errors, it would have not generated the .exe. Okay, fine. So one thing I can show you here that if let us say I delete it, .exe, I'm going to delete it. I deleted it. Okay, now there is no .exe. So now I can do something like this. I have only test.cpp right now in my current directory. So g++ test.cpp. So you see, it generated a.exe. So what is a here? A is the default name given by the compiler to the output executable. So let us say if I want to tell that, okay, I want to give this executable name test.exe. Okay, same name, same file name .exe. So how I can do that is, let us delete, remove. Oh, sorry, a.exe. Yeah, so the a.exe is deleted. So g++ minus g, what was the command over here? So cpp minus g, then file name minus output file name and .exe. So file name is test.cpp and minus o, okay, test.exe. You see, the test.exe is generated. Exactly, if I want to give any blah blah .exe, so it will generate a blah blah.exe. Okay, you see this one. So this is how a program is built. So what this task.json is doing, it is doing nothing but just compiling your program. That's it. So if let us say I have written here that compile this particular file, the active file. Okay, the active file. So it will just compile this one. But let us say if I want to compile all the CPP in this directory, then what it will do is, what I need to do is, I need to provide something like this. Just a second. I think in that case, we need to provide it something like, yeah, in here, instead of, this file, this all file directory name and all are system defined or the environment defined variables. So we can write something like this, and then / star dot cpp. So this will compile basically all the .cpp files in this directory and then generate their executable name, executables with the same name. Okay, so now up till now we are very clear up till here. Great. So now let us move to the next topic, which is our, so we have seen that, how the G++ compiles a C program, C++ program, or same holds for the C program. And we have seen that what is a task.json. So this is basically for building instruction. Okay, now we will look at, there are two more important JSONs, which are basically launch.json and CPP properties.json. So launch.json is for debugging settings. So if you're running a debugger, you have to set certain parameters before it. Okay, so launch.json is for setting those parameters. Similarly, the CPP properties are for setting the compiler paths and the Intellisense setting. We will just look at it in our next step. Okay, so now let's move forward to our third step, which is debugging a C++ program. So for enabling the debugger in your Visual Code, you need to go to the run, and then you can just, for example, this is your task.json. If you click start debugging, what will happen here is, sorry, Obviously the stars.json will not be a debugger, debuggable code. So what will happen here is that it will ask you to select the environment. So we have just selected the C and C++ environment, this one, just for showing it. Okay. So as soon as we have done it, we have tried to run this task.json. What it is saying, you can see that launch program and program name, for example. Okay. So it is trying to launch something like program, enter program name, for example, this one, and does not exist. So from where it is coming? Okay. So you can see here, as soon as I just, clicked start debugging, and another file called launch.json is generated, this one. So this launch.json is generated for the debugging setup. Okay. So here you can see that, the name is this one, type is this particular thing, program, this line number 11, you see, program is this one. So here it is asking you to enter the program name, okay, which you want to debug. So right now it is written here, this thing. That is why we were saying, this same name in that error box. For example, in this test.cpp, if I'm running and start debugging, so this debugging window is coming, but the name it is coming as launch program, enter program name, for example, this error is just coming. So in order to resolve it, what we need to do is in the launch.json, we need to change the program. So what we will change the program to? We need to change the program to the active file. Okay, because that is the file, executable of the active file. So what is that executable of the active file? Because that is the executable which you want to debug basically. So how you will mention it, that what is the executable of file? Executable of the CPP code. So this is, you can write it something like file directory name, and then I think yeah, this should come actually here. So you see, this is, I'm telling that, okay, in file directory name, whatever the file base name, okay, base name without any extension, take the executable of it. That is my program name. Similarly, there is one other parameter called min debugger path. So it is asking this, defaultly generated launch.json is asking that please set the path to GDB. Okay, so you remember we have set the path to the binaries. Okay, so we need to bring that path, so that the path of GDB. So what was the path? Yeah, this one, right? Binaries. So based on your system, you paste here the path to your binaries. Okay, and then gdb.exe. Don't worry at all. I will just provide all these informations in this video description. Okay, whatever things I'm doing, I'll provide all those information. So I'm just escaping this backward, sorry, this forward slash. Okay, so now this is my GDB path. Similar to that, there is another parameter called stop at entry. So what it is doing is, this is an optional parameter. If true, the debugger should stop at the entry point of the target. So yes, in the debugging, what is the process of debugging? Basically, we provide certain breakpoints, and we want our program execution to stop at those breakpoints, so that we can monitor stepwise that how our program execution is progressing and how it is reaching each of the breakpoints and so on. Okay, so yes, obviously we want our program to stop, okay, at entry of those main method, main function. So this is set to true. Okay, now there is one very important point here, that if you'll notice here, in the task.json, we have this label. Okay, what is the label? C++ CPP program build active file. Okay, so if let us say that with this setup, this three things setup program, stop at entry and this debugger path. Okay, so after these three settings, if I feel that okay, everything is set up correctly, and if I run the debugger, so just focus that what is happening right now here. I just ran the debugger, so this utility is coming up, and the terminal is opening up. The GDB will be launched. You see, the GDB was launched. Debugging console came up, and it will by itself, oh sorry, I forgot to put a breakpoints basically. So let us stop the debugger, and let me put the breakpoint at here in the yeah here in the cout here, and at the end let's say here 4 breakpoints just for a demo purpose. And now when I'm launching this run debug console, so what it will do is it will finish without even stopping. That is what I feel. So yeah, so you see all the local variables are coming, but let us say when I'm clicking at this, okay, great, it is working. Oh, okay, fine. So how my debugger is working is like, this button is for the step over, obviously. So using this button, it will not go inside any of the functions. It will just step over the breakpoint, and it will not go inside any of the function and all. Step into is basically for going at each of the step. Okay, so it can go to your header files also, or any utility files also. Okay, so I'm just doing it. So here I can add the watch variables also. For example, I'm interested in seeing the value of I. Similarly, let us say I'm interested in seeing the value of let us say Q. I'm interested in seeing the value of let us say message, and so on. So obviously these all are the local variables and it is already listed. But if you are specifically interested in watching a particular variable, you can include that variable here. This is a call stack. It is telling us right now that there are 4 threads being launched for this execution. These are all our 4 breakpoints, and this is our local variable window. Okay, so I can just continue, or the execution will finish with this button. This is for step over. So I'm just clicking step over one by one. So you can see that the value of I has increased now because it has finished one iteration here. So now again, you can just focus here that 0 is printed. Now the execution is at this step. If I'll click this one again, so 1 will be printed in the terminal. So you see the 1 is printed and so on. Now 2 will be printed. Okay, so now 2 will be printed, and now the value of the I is basically will be incremented to 3. Okay, you see it has become 3, and as soon as it has become 3, this if condition will be met, and this will hit a break statement and it will come out of this loop. So this is how it works. If I'll just click step into, so it will go inside each of the loop, and for example it has reached now q.push, so I feel that it will go to the q.header file. Okay, something, yeah, you see stlq.header file. Oh sorry, I clicked it 2 times, so it went from q to the move.h and all those, like it will go at each of the step. So obviously nobody will want to go and debug the header files, the system files and all. Okay, so that is why nobody clicks this step and step out unnecessarily basically. So this is how basically works. Let me just click continue and come out of this. So okay, so this is how the debugging works. So now we have but I will say that in some of the places I found that there is one more parameter called pre-launch task, which means that what are the tasks you want your launch.json to finish before launching the debugger. So I have found in some of the places it is also suggested that to include this particular key value, that pre-launch task, it is set to the same label name which you have set here in the task.json. So here the label name is C, C++, CPP. Same exactly, you just copy paste this value here. Okay, so if you are hitting some issues and your debugger is getting launched and without even waiting for anything, it is simply getting executed and finished without waiting for you to click continue step or step into something, then I think your issues can be resolved with this. Okay, so this is what it is about the debugging. We have just for the sake of telling, let me explain that here when we were selecting run add configuration here in the run, where is the run add configuration? Yeah, add configuration. So here, we can search for, oh, not here actually. Already we have generated this launch.json, but when we didn't generate this launch.json at that time, if you will go to run add configuration and you would have searched for C, C++, there's one, not here. Okay, we can leave that. But the point here was in the option, it was showing that you want to set it for the GD and LLDB. So GDB is nothing but it is a standard GNU debugger, and it is mainly not the debugger only for the C++, but it is a very generic debugger in the Linux operating system, you can say. And it is a generic debugger for lots of programming languages like Ada, C, C++, and so on. Similarly, it also included a point that the debugger you want to set it up for LLDB. So LLDB is nothing but it's an Apple's version of the GDB. You can say that in a very simplest language or in a very simple approach. You can say that. Okay, so now just we have seen that how we can set up the debugging, and now everything is working for the debugger. So at the last step, if you still want to configure some more parameters into your C, C++ development environment, then what you can do is you can open the command palette using the Control Shift P, okay? And then right there, C, C++ edit configuration UI. So let me just say, oh, sorry, just remove this. Okay, and let me come here, Control. I want to disable all the breakpoints, so deactivate the breakpoints here. Okay, Control Shift P I am pressing, so this came up. So here the first option you see, C, C++ edit configuration UI. If it will not come as the first option, you just need to type. So as soon as you open it, you see as soon as you opened it, a third file is now getting generated, C, C++ properties. Okay, let me just open that also. So this file is generated, and here some points to be noted. That name, this is, you can name it anything, whatever you want. Include path. So what is the include path means that this is the path which is included as an from whichever paths a executable or the header file should come. So this is that path. Okay, so in some places what will happen that some of the header files are not found, or in those kind of errors you have to include those paths also here. For example, let me just I have for example, let us say if some of your header files are coming from um, main, so you see there are lots of folders here. So let us say if I'll go inside the lib and then GCC, so there is this x86 64-bit this one. Then let us say we go inside this one. You see lots of header files, include files are there, right? These header files are there. So let us say if you are including some of the header files from this particular directory and it is complaining that we can't find that, then what you will do is you have to basically include those header files here. So now it is giving error because it is expecting that this is a forward slash, and you have to basically escape it. So you just need to provide it double times so that Okay, something like that. So now this path is also basically included. So, okay, like this. So generally, I found that there are lots of paths here, and we need to include all of them. So I have just copy pasted it somewhere, and this is the basically path. So now I'm going to replace copy include up till here. So basically, this is all my um, paths. Okay, sorry. So yeah. So basically, you just need to find that, if that particular thing is existing in which path, and you have to include like that. So that is the whole point of this exercise of including the path. Similarly, here you see your Intellisense is which one, like it is a CLang X64. Similarly, your CPP standard is this one, 14th version, and your C standard is the 11th version of the C. Your compiler path is GCC, this particular one. So if something goes wrong, you just need to make sure, in your environment, everything is working fine and everything is, set properly. So that is the whole purpose of explaining the importance of these three files: C, CPP properties, task.json, launch.json. So I think with this, we have discussed all the things regarding the C++ development environment setup. Okay, so just to recap, we have discussed setup visual code for CPP, then how to build a program or multiple programs in a particular directory all together at one go, and what is basically the process of compiling a.out, a.exe, and generating a user-defined name for those exes and all. And we discussed about the debugging of a C++ program, and finally the importance of C CPP properties dot JSON file and how we can configure some of the more paths into the properties file. So thank you very much for being patient up till here. If you benefited from it, please like the video and share it among others. Thank you.